Dear guests, it's my pleasure, both that are currently present here and those that are watching us online and those that will watch us afterwards in YouTube. It will remain there accessible. It's my pleasure to open the second session of our forum. It is consisting of, in fact, two panels. The one is dedicated to the industry. Here we'll have presentations of 8 leading companies in the area of microelectronics and mechatronics. And the second last panel will be a roundtable, which will be held here. So it will be in a form of studio, informal communication and dialogue. But still, we are ahead of the panel with the industry. Our first presenter will be Sylvain Collot. He is the site manager of Melexis Bulgaria. This is one of the leading companies and let's say with more than 20 years of history presence in Bulgaria. Their branch outside of Belgium is in Bulgaria is the biggest non-Belgian branch. So Mr. Sylvain Collot is also a member of the managing board of the cluster of microelectronics and industrial electronic systems. We are in regular contact and have put a lot of resources in the past year in order to maintain and boost the achievements. We mentioned that our achievements are in at least three directions. One is the priorities for Bulgaria, second is the consultative microelectronics council, and the third is the inclusion of microelectronics in the smart specialization strategy. Sylvain is quite active in this area, he is supporting. Also, I would like to thank personally to him that without his help, we could not realize today's event in terms of logistics. So, Sylvain, it's my pleasure to give you the floor. Please proceed.
Thank you, Georgi. Can you hear me well?
Yeah, we hear you clearly well, which is surprising, but still we hear you. You may go.
We'll see how long it will stay like that.
Yeah.
Okay. Thank you for the introduction, Georgi. It was well done. Thank you for that, and thank you for organizing. Good afternoon to everyone. Let me share my screen first. And starting by, I don't know if you can see my screen now.
Yes.
Yeah. So first of all, I don't see you anymore, so I see only my screen. First of all, let me first apologize for not being with you today, physically in the room. It's a great event that is organized today, and yeah, I would have loved to be with you. I had to deal with my commitment, and I'm now in Varna with the Belgian business community, which is another responsibility. So, meaning online. I'm honored to open the industry chapter of today. I will try to make the coming 10 minutes interesting. I heard some interesting presentation before the break, so I will try to keep the tone there. In this today 10 minutes, I want to focus some views and thoughts related to one of the common ground that we have between microelectronics and mechatronics, innovation and innovation topic and our highly growing needs in talented engineers to continue our development. That's why I call it a priority for all of us. Starting from us, Melexis, we are a true and successful engineering company. Some facts and figures might illustrate that. We create innovative semiconductor solutions for the best imaginable future. We develop and sell innovation. We sell solutions to our customers in automotive and beyond. We'll see later on that we have also quite a number of applications that we are delivering as well, mainly in sensing and driving solutions, but also in lighting solutions. Not only mixed signal silicon, but also application for safety critical and availability critical in harsh environment. We are in offering microelectronic solutions. We are creating microelectronic solutions, and as I said, mainly automotive. But as you can see on the right of the screen, a lot of various applications as well. We face technical challenges that are given to us by our customers or by our research, and we need to working in the domain of more sustainable homes and cities, or current sensing or embedded solution to drive Internet of Things connections. More and better environmental sensors will emerge to measure air quality, water quality, monitor mechanical properties of buildings, smart lighting. So a bright future in front of us. I think that I don't need to convince any of the people in the room now. Successful we are because we, just a number, we delivered in 2021 more than 1.7 billion chips in the world, which is, of course, our top record in our history. Now, concretely, what do? We do that since more than 30 years, Melexis worldwide, and more than 20 years now in Sofia. We have a defined definition of the chip. That is the first part where we have to make sure that the chip fully meets our customers' needs. So we collect all information of the chip function, operation condition, and we integrate that into the definition of the chip. We design them, the chip, the package, the software. We'll come back to it. It's a work done by our system architect that to develop the plan. The blocks are then implemented by design engineers using all the elements needed for that to build a virtual circuit and the mathematical model that will make it work. We have today, just to give an idea, more than 15 products under development in Sofia, new product for customers under development. Then we layout them. We arrange the chip into a usable format by the foundries. We outsource the manufacturing of the wafers, and then we receive the wafers to be tested and to be probed at first. We also develop the test solution at wafer level and at assembled chip level. And this test solution development, being from machinery, being from tester, being from software, is also something that we are developing. We also the packaging of the chip in Asia mostly, like most of the business today. And then we receive them for a final testing where we will be trimming them, calibrating them, testing them in temperature, in condition, stimulus, and delivering to the customers. I mentioned about 1.7 billion chips done in Melexis. Sofia only is, for 2021, is almost a billion by itself. So just to confirm the word mentioned by Professor Anita before, we are the biggest site of Melexis today. We are a worldwide team, Melexis, and we are approximately 1,800 people worldwide with 750 based in Sofia. 50% of us are being engineers, are graduating engineers. This is visible on this slide with the number of boxes that you can see, the 3 boxes of the major activities we have in Sofia. And you will see a lot of engineering activities around design, layout, test, product verification, software, and so on. But also in operations, lean engineering, process engineering, equipment team, and in business foundation with the IT engineers that are also important part of it. So we have a commonality with between microelectronics and mechatronics in Melexis and in our activities. The list is long about engineers. I can even say that actually our management is mainly engineers as well. 75% of our executive team is having a degree of engineering. Our CEO is an engineer, so it is just embedded in our work and in our nature. Melexis is a tagline that you can see on the top left of the screen, which is the website. Melexis, the tagline is "Inspired Engineering." So just to emphasize on the engineering purpose that we have. Now, today we have a need for talented engineers that is growing, that is continuing growing, and it's for us, but it's also worldwide and for the whole society by itself. I will not pretend here to elaborate on a full thesis on the need of engineers and the reasons why we need that, but just to give some elements that I could, let's let's say, extract from the different readings and different interactions I can have within people around. First, obviously, many businesses over the past decades have took decision to change their organization and to have more and more engineers in other roles than engineers. I just mentioned the management of Melexis, but it is also valid for sales. It's also valid for even HR team are also with engineers in head. And the principle behind is it's much easier when engineers talk to engineers. So that's a tendency that make more opening for engineers, but also making the engineer more look for resource. As well, the automation robotization that is illustrated by the picture on the top right is of course an element that makes it more and more complex. And basically, we are moving out over the past decades from manual operations to automatic operations. So where the needs of engineers in automation, mechatronics in development is increased as well, and is continued to increase. High-tech is getting everywhere. So coming back to microelectronics, if I take Melexis, the portfolio of Melexis, you can see on the bottom left, yeah, we use the chips everywhere today, and it's continuously growing. We have a trend of having chips used in gaming, of course, but also in appliances or in smart houses and stuff like that. Even in cars, the car is also for us the driving element. Today we have something like 18 chips per car being assembled, and we can, in some models, exceed 150 of them, I think, in the latest Tesla model. Now, we are also to face, related to engineers, also to face environmental and societal challenges that require innovation and solution. And engineers are developing that, are the ones developing this solution. The last element I wanted to mention is illustrated on the bottom right is the situation in terms of population, in terms of our engineering crew. We are facing that the baby boomers are retiring gradually now, and we need to replace this accumulated experience and knowledge and expertise with fresh blood. And in many cases, we see it ourselves in Melexis. In many cases, we cannot replace one of these baby boomers with just one person. It has to sometimes be spread into 2 or even 3 other engineers. So it just, by nature and by this replacement, just inflating the number of engineers that we need. And it's a very important step to do because it's a source of knowledge that is so precious to keep on. This trend is also difficult because if we look to what's actually happening, we have to face a number of attacks or a number of elements that are making this engineer important. First of all, the engineer studies, I heard it before the break, but the engineer studies are difficult to reach a graduation. And it is competing with other paths for good job that are easier. There is even a belief or a flow illustrated on the top right here that yeah, with the 4 months and a tutor on YouTube, you can become a programmer and make a lot of money and enjoy your work. So that's what we have to compete with, and that's a reality that we have to face and to be able to address. As well, we see, and we discussed that with Professor Angelov and Collot in the cluster of microelectronics, we see also a number of engineers that are graduating but not staying with us. They are moving in other disciplines. So that's what is mentioned on the bottom left. 30 to 50% are working something else than electronic or microelectronics today. And this is a trend that is also seen in other countries. It's not a Bulgarian problem. It's in other countries the same. Many of the engineers are not staying within the domain. Another element is related to the instability of the business. In a fast-growing country, the globalization of the world, there is movement of companies between countries, and it creates instability and creating a kind of fear within students and parents to embrace careers where it can disappear soon. So it's not helping them. And the last but not the least, on the bottom right, is related to the population. And here is the curve of Bulgaria, where we see that we have a a population that is not renewing at the pace that it is in a healthy way. Recent numbers from census were published, so we have less people in Bulgaria, and this will not help into renewing our team. So this must be taken as a priority for Melexis. We take it as a priority, but the whole sector, the whole microelectronics sector has to take it as a priority. With or without EU Chip Act, doesn't matter. We have to face this if we want to continue developing ourselves. Some ideas. Again, I'm not gonna make a thesis out of it, or I'm not gonna. It's not, how to say, rocket science, but just important element I wanted to mention here. First, about transparency and clarity on the sector. We have to clarify, we have to be transparent of what is being done and who is doing what and what are the sectors, what is in the sector, what is the jobs that we are doing, what are we doing, what are we aiming. Second is about unity. It's so important, and today is a good example that let's say the four key players in these domains are working together jointly. Authorities, education, research, and industry. All of them have to unite efforts, and they have to work together to have one common plan. Even in Bulgaria, I mean, it's even more in Bulgaria because we are, let's say, not a necessarily very large country, so we have to unite force to get it through, and not to play in parallel path, because it will just divide our effort and lead to less result. And the third element to say is about the purpose. Many studies shows it. We have to create a view on the purpose of our jobs. What are we creating? We are engineers. We are creating solutions. We are creating systems. We are solving issues, and we have to create this view and this link to the how. Engineers are changing the world. That's basically since century like that, and it has to we have to continue it and make it clear. We have to face the reality that we are having now the Generation Z coming to work. In 4 years, they will be 30% of the whole workforce. And this generation has, have a number of definition or a number of elements that is driving them. And one of the reasons related to business is that they want to solve social problems. They want to do something that is relevant. They don't want to do a job for a job. They don't want to do a layout here of a chip because it's nice to do a layout, but they want to know where it goes. But okay, we face this, and basically all our technology and our chips are helping to face this kind of technology. In temperature sensing, for example, Melexis, we have a wireless, a contactless temperature sensor that helped into monitoring temperature in the distant way, which was so important during COVID time. So it's just an element, but also in systems like respirators and ventilators, where we had devices including that latch and switch, for example, that were playing a crucial role into this device, into this component. Just one sentence to conclude. I think most of the time. To conclude one sentence, we need to solve a number of societal challenges, and engineers, microelectronics engineers, are a must to do so. So we have to take this as a priority, all of us. Thank you.
Thank you, Mr. Collot, for this really great insight about and that you raised the topic about the talent, of course, when we're talking about technology. The purpose for us all as a community is, of course, to increase and inspire more people going on to choose engineering career. Thank you again for being here with us and share such a great know-how, and thank you being on board with us today. And our next presenter is Mr. Simeon Kostadinov, who is the manager of GlobalFoundries Bulgaria, who will share with us more about the anatomy of the chip. So please warm welcome, Mr. Kostadinov.
Благодаря. Здравейте! На мен се пада удоволствието днес да разкажа за анатомията на един чип, но преди да започна да говоря за чипове, искам да ви покажа един автомобил. Той се движи с 100 милиона километра в час, изразходва 20 мл гориво на 100 км, тежи само 50 грама. Бихте изминали разстоянието до Луната за 13 секунди. Звучи доста фантастично и нереално, нали? Така би изглеждал съвременния автомобил обаче, ако автомобилната индустрия следваше тенденциите на развитие в електрониката. Но да видим как това развитие промени всъщност компютрите. Вляво е показан нововъведения през 1950 година компютър ENIAC. Той прави революционен скок в ефективността на изчисляване на данни. Успява да изчисли траекторията на движещо се тяло за около 30 секунди, като същите тези изчисления са отнемали 20 часа на един човек. Така, този компютър с размери колкото малка къща е успявал да замени 2400 човека в сложни изчисления. Консумирал електроенергия като за 50 домакинства и е тежал колкото 10 автомобила. Днес, около 70 години по-късно, след поредица от технологични пробиви, съвременният процесор прави същите изчисления стотици хиляди пъти по-бързо. Побира се в дланта на ръката ви, консумира електроенергия колкото една електрическа кружка и струва 10 000 пъти по-малко от ENIAC. Освен компютрите, това развитие е променило и телекомуникациите. Телефонът с шайба е класическия начин за провеждане на разговори на дълги и на кратки разстояния. Дълго време той е разпознаваем от мнозина от нас. Представете ли си в нещо забързано ежедневие, да трябва да се разберете за кратка среща с приятел от предния ден или за да се чуете по телефона, да трябва да се приберете вкъщи, да изчакате до вечерта, когато той се прибере от работа и да му се обадите. Доста непрактично, нали? Но въпреки, че е толкова разпознаваем, не всяко домакинство имаше домашен телефон преди повече от 30 години. През 80-те години на пазара се появява и първия клетъчен телефон, който е дори още по-недостъпен от телефона с шайба. Той струва $6000 и тежи около килограм. Не случайно носи прякор тухлата. Въпреки, че минава през доста разновидности, телефонът запазва своята основна функция дълго време, а тя е именно предаване на гласови сигнали. От тогава, през 90-те години, именно телефона с шайба става проводник на един изцяло нов подход за предаване на информация. Този звук е познат на хората на моята възраст и на малко по-големите. Започнахме да предаваме и данни по телефонната линия през 90-те години. Модемите ни даваха възможност да сърфираме в интернет, макар и бавно, и можехме да свалим любимата си песен за около 20 минути. Освен това ни гарантираха и скандал с съседа, ако ползвам обща телефонна линия с дуплекс, тъй като докато ние сърфираме в интернет, той не може да говори по телефона. Днес технологията се развива до такава степен, че в джоба си имаме безжичен телефон, който обединява изчислителната мощност на 50 000 компютъра като ENIAC. 5G свързаността ни дава възможност да гледаме филми с резолюция 4K в реално време. Любимата си песен можем да свалим за една секунда. Освен това, на практика разполагаме с неограничено облачно пространство, което да качваме снимките, които сме запечатали с камера с висока разделителна способност, която ни е бонус. Всичко това за няколко стотин лева. Какво се крие ключът към този прогрес обаче? Всъщност е предсказано още през 1957 година от Ричард Файнман, по-късно обединен в емпирична зависимост от Гордън Мур, ключът се крие в миниатюризацията. И както е предвидил Гордън Мур, на всеки 2 години броят транзистори на единица площ в една интегрална схема се увеличава 2 пъти. Пропорционално ще намалява себестойността за производство на всеки един транзистор. Всъщност тези транзистори играят ролята на електронни ключове, които извършват изчисленията в една интегрална схема. И ако се върнем пак към компютъра ENIAC, неговият основен градивен елемент също е бил тази електронна лампа, която е била с размерите на кружка за фар и горе-долу е била толкова, е приличала на също. През 1971 година електронните ключове са заменени с транзисторни и на площта, която първоначално е заемала електронната лампа в ENIAC, сме можели да произведем 40 000 електронни ключа, които имат същите функции като електронната лампа. За да ви илюстрирам колко е бил голям всеки един от тези транзистори, съм показал едно насекомо. Всеки транзистор е бил по-малък от главата на тази бълха. Днес технологията се развива до такава степен, че на същата площ, която е заемала лампата, вече можем да произведем 160 милиарда транзистора. Всеки един транзистор е с размери, колкото познати ни през последните няколко години вече, коронавирус. Аритметиката е проста, колкото повече транзистори имаме на единица площ, толкова повече изчисления можем да направим за единица време. Или грубо казано, компютърът ни е по-мощен. Но как успяваме да произведем толкова много транзистори? Благодаря. Как успяваме да произведем толкова много и толкова малки транзистори на едно място? Бих оприличил стъпките за произвеждане на една интегрална схема с готварска рецепта за приготвяне на торта. Както тортата, така и чиповете са изградени на няколко нива. Важно е да имаме правилните материали в точните пропорции и трябва прецизно да следим температурата на всяко едно ниво. Ако за приготвяне на торта обаче, дори по сложна рецепта, следваме 30 стъпки, при производството на една интегрална схема стъпките са стотици. Ако трябва да прекараме 1 час в кухнята, за да направим торта, то силициевата пластина преминава през технологични стъпки в фабриката за около 2 месеца. И не на последно място, фурната, с която разполагаме в фабриката, струва няколко стотици милиона. Знаете ли какво е това? Точно така. Това е човешки косъм под микроскоп. За да илюстрирам прецизността на машините, които се използват за разработване и производство на интегрални схеми, съм показал този напречен срез на косъм. Ако всеки един транзистор в една интегрална схема от последно поколение заменим с буква, следвайки производствения процес от фабриката, можем да изпишем цял том от енциклопедия Британика на напречния срез на този косъм. Говорим за такава прецизност. Но да видим на практика как протичат производствените процеси в фабриката и какъв е пътя на един чип от шепа пясък до компютъра ви в следващото видео.
You are about to experience a fascinating journey through the clean rooms of the semiconductor industry. See integrated circuits in the making at one of GlobalFoundries chip factories. Let our experts walk you through the nanocosmos of the atom. In the beginning is the circuit diagram. At design centers around the globe, experts collaborate to design circuit diagrams, sophisticated integrated circuits like microprocessors, high graphic processors, and wireless communications ICs. The next step is manufacturing. The disk substrates for the microchips are made from quartz sand and are called silicon wafers. To make these wafers, a huge monocrystal is drawn from purified silicon melt. The result is a perfect silicon lattice into which the transistors will later be fitted. However, impurities pose a threat to these flawless silicon crystals. Completely free of dust, the silicon discs arrive at the clean room. Here, 25 wafers are packed into each hermetically sealed container and sent off on a journey that will take them through hundreds of manufacturing steps. Photolithographic techniques transfer the circuit structures to the wafers, rather like slide projection. The key to this whole process is a solid mastery of light. The silicon disc is spin-coated with a photosensitive resist. UV light transfers the circuit structures depicted on a mask to the wafer. The exposed parts of the resist are soluble and are removed by a developer. The transferred structures can now be used as a template. The unprotected parts of the water surface are etched away. The structures of billions of small current switches are generated on each wafer, tiny transistors. From the photolithographic stage, wafers move on to the ion implantation, where the electrical properties of the transistors will be specified. First, dopant atoms are injected into the silicon structures. These atoms then distribute randomly in the silicon lattice. At high temperatures, the doping atoms become flexible and take on a fixed position in the atomic structure. The complexity of manufacturing tiny transistors requires a clean room as big as 2 soccer pitches. Copper dominates the next process step. The finest interconnect wires link up billions of separate transistors to form integrated circuits. Before the copper is poured into the trenches for the interconnects, a barrier layer is applied. It helps to avoid short circuits and guarantees reliability. The trenches are then filled with copper. Finally, the excess copper is ground down to the edges of the trenches. This insulates each interconnect from the others. A microchip made of copper wiring established GlobalFoundries as the first company in the world to adopt copper in volume production. A foundation for the state-of-the-art multi-core processors that GlobalFoundries is introducing today in all product areas. To keep us on the leading edge of the world's chip makers, electron microscopes constantly monitor every step in the manufacturing process, down to the atomic structures of each individual transistor. In 2 months, the wafer is ready. Huge integrated circuits consisting of conductors with a length of multiple kilometers link up 100 billion transistors on numerous levels. And that in a space no larger than a fingernail.
Благодаря ви за вниманието.
Благодаря на Simeon Kostadinov. I would like to draw attention that he is a good example of our engineering human resource building, let's say. He was a student with our Faculty of Electronics, master student of Microelectronics, and now he's a prospective young manager in GlobalFoundries, one of the top 5 companies in the business worldwide. So yeah, this is especially targeted to our young audience, our current and future students. So yeah, the path forward is clean. So next is a very important presentation. It will be delivered by our partners from Infineon, Austria, Mr. Martin Mischitz, who is very active in cooperation between Infineon and external parties such as universities. It was a pleasure to have a lot of contacts with him personally and his team in Austria. So now the floor is his, and it will be our pleasure and my personal to hear the presentation of yours. Please, the floor is yours.
Yeah, good afternoon, everybody. Hello, George. Hello, Dimitar. Thank you very much for giving me the opportunity to present here. Thank you very much. Yeah, it's a pleasure to give you a short insight into Infineon technology. Maybe it's a bit short, so if everybody, if further information is required, please don't hesitate to contact me. First, I would like to give you a little insight into Infineon as a corporate. Infineon is known to be a global player on the semiconductor market. We are having around 50,000 employees, and our products are mainly located or can be attributed to automotive industry, to power management, energy efficiency technologies, and Internet of Things. Our products are strongly contributing to decarbonization and digitization as global trends that are very important, not only since a few months, as we know, but already for a long time, and in very important market areas like automotive, electronics, power electronics, and microcontrollers, for example. We are holding top market positions. To give you a few key numbers of our company, you can see here in the last year we had a revenue of around 11 billion euros and a result margin of roughly 19%. Our 50,000 employees are located in Europe, in Asia, and in America, and we have roughly not only 19 manufacturing locations worldwide, but also a huge number of R&D locations distributed to all these continents. To give you a little insight into the big applications of Infineon, our products go into energy efficiency, serving mobility, security, Internet of Things, and big data applications. Here, for example, energy efficiency, we are providing products that help and are applied in power generation of renewable energy resources, not only, also classical energy, electrical energy generation, of course, is our big market, but nowadays all renewable energy applications are, of course, key areas for our products. Energy transmission and distribution is strongly dependent on energy efficient power electronic devices, and Infineon is supplying very many of them. Energy storage and energy usage in a very efficient way are also those areas down to your personal application that you have in your individual household. You will find our products, and I'm very sure that most of you are using Infineon products in your everyday life without knowing that. Mobility as a huge sector and as a huge factor in our society is also a strong market for us. Not only electromobility, but even before that, Infineon was serving already for many years applications in electronic applications in classical also combustion engines, combustion motors, so classical mobility, but electromobility now even is more making use of our products. Charging infrastructure is also a key application, as well as autonomous driving, where sensors of in different areas are used, that are developed and produced by Infineon. Beside that, of course, everything which makes our situation as a passenger inside the car more attractive will also be supplied by Infineon. In the security area, our devices are used for embedded solutions in order to improve the connectivity between different devices, mobile devices, very important authentication of Internet of Things applications are a key area, smart card applications, and very many features in the industry, but also in the personal application where data transmission is used. Internet of Things, already mentioned, is rather a younger market of Infineon, but a strongly growing one. So everything which is related to human-machine interactions in the consumer area as well as in the industrial area, and everywhere where data and communication infrastructure is required, our products are supporting them with different applications, from sensor, microcontroller, and even to the power semiconductor applications, MOSFET solutions as well. To give you an overview where we are located, the center of Infineon is located, of the corporate is located in Munich, but there is no production, therefore you cannot see it. But in Europe, we have production sites in Germany. Regensburg and Dresden are two locations with large factories. And here we are distributing between front-end manufacturing and back-end manufacturing, so wafer production in the front end and chip package production in the back end. So is distributed. And furthermore, there is Warstein in Germany, Ceglet in Hungary, and Villach in Austria are big locations. And as you can see, a group of factories are already also located in the US and Mexico and different countries in Asia. We are happy to serve very many large players on the market and have them as our customers. And you will usually find their labels on your products, and you will not find, unless you are opening your devices, that there are a lot of Infineon chips inside. Inside the corporate, this international corporate, Infineon Austria plays a special role as a very large legal entity inside the corporate. So we have about 10% of all employees of the corporate, and have, for example, two design centers in Austria, one in Linz, one in Graz. Another one is in Villach, but Villach is actually the headquarter of Infineon Austria, and also the largest location, containing not only design, R&D, but also production facilities, and I will show you a bit more in the next slides, but also business responsibility, so marketing and also IT. So the location in Villach, which is in the very south of Austria, close to the Slovenian and Italian border, we are concentrating a lot of features of our corporate, and are very happy to be able to provide here short communication ways between these different disciplines in order to guarantee the success of the company. As you can see here, Infineon Austria alone is spending roughly 500 million euros for research and development per year. So these are the numbers for 2021. This means 13% of our turnover is used for research and development. We are very happy to expand the production, where we were very happy to expand our production capacity, as you can see here, as a review of our site, with a new highly automated fab, which went into production 1 year ago. So this was an investment of 1.6 billion euros, doubling the production capacity of our fab here in Villach. And this is this building, as you can see here, is a highly automated manufacturing factory for 300 millimeter silicon-based wafers. But this also is, so we are not only known to provide here silicon-based applications, but also wide bandgap applications. As it is well known, these three materials are at the moment on the market in order to serve many applications with their specific features. And Infineon is not only Infineon Villach, so in Austria, is not only able to provide here access to this technology in silicon, but also silicon carbide and gallium nitride. These new wide bandgap materials are known to offer very interesting and beneficial properties, especially in the area of energy efficiency, helping not only helping to support here new solutions which are smaller, losing less energy, having less cooling effort. So a lot of consequences that a small, more effective chip can lead to more lean, small, and cheaper solutions in many areas of different products. Silicon carbide is one of the key competences of Infineon Austria in Villach here. For more than 20 years, we are now active in this area, and we are still, of course, so silicon carbide is a quite new area, but still subject of a lot of research and development, especially to make it accessible in high volume production. And this is going on at Infineon Villach. We have a very long tradition, not only Infineon as a corporate, but especially also Infineon Austria, to work together with research partners for a long time, mainly focusing in Middle Europe. Universities, research institutions, other companies are working together with us in bilateral projects, but also in very many funded projects. And Infineon now is continuing this tradition in order to reach out also in the context of the project IPCEI for microelectronics, which many of you might already know. IPCEI on microelectronics is an initiative of the European Commission in order to support here all activities that help to make Europe more competitive, to make it more sovereign in technological know-how, bringing high-tech products to the market, a tendency which is not only going on in Europe, as we all know, but also in other areas, the US and China, of course. And this initiative is supporting companies that bring innovative technologies made in Europe fast to volume production and to the market on one hand, and in Infineon Austria's case, these are technology developments in the area of silicon carbide, and gallium nitride, used supporting energy efficiency applications and electromobility. Beside that, there is another big motivation for this IPCEI activity is to strengthen the European network inside the industry, but also between the industry and the academia. So we are very happy to exploit now and explore now new contacts all over Europe. And Professor Angelov already mentioned that we are already in a longer contact now, looking for cooperations with TU Sofia and also other universities in Bulgaria. And one part of these activities is called spillover. And what we are doing here is offering to new partners in academia opportunities for collaboration with us in the area of R&D, but also in the industry sector, in this supply chain, where small and medium enterprises, startups, but also larger enterprises are interested to cooperate with Infineon. So we are very open here and looking for new opportunities in order to strengthen the situation of the universities on one hand, but also on companies on the other hand, at their location, so in their home country. And we are very open to proposals. In principle, of course, one activity is directed towards the area of talents, of young talents, to support them with not only with partnership projects via the university, but also directly offering internships, PhD and master scholarships for the people working at their home university. So, for example, in Bulgaria, at their home university, but also offering lectures, teaching of Infineon experts coming to your places, bring hardware and also training material via different channels. Yeah, so this is covering a wide range of competences where we want to find out where are the best opportunities, where the fields of studies of the universities. So Infineon is here covering really a wide range of the natural science, of industrial engineering subjects, material science, mechatronics, very many different competence fields at the universities can support here our fields of applications at Infineon. As you can see here, named just a few of them as a non-exhaustive list. This is the point to end, and I hope I could give you a short overview about Infineon Austria and our activities, and also the offerings that are, of course, be explained more in detail also by our homepage or direct contact. Thank you very much.
Thank you very much, Martin. It's impressive. I want once again to stress that it's key for us, your partnership and your deeper involvement with our ecosystem. And I would like to say from my personal impressions since the past year, that in fact everything that Martin Mischitz said is true. This is a really open company. This is not just work, this is their passion of working. We started some activities. They're pretty open. We have worked in our experience with a lot of foreign companies, but Infineon is a good example for combining the commercial part with the R&D and the open attitude towards cooperation. So thank you very much, and I'm happy that you are on board today with your presentation.
Thank you very much.
So next is ASML in the Netherlands, Velislava Ignatova. It's my pleasure that she changed her agenda in order to participate in today's event. So, Velislava, it's my pleasure to introduce you to our audience, both in person here and online, and to give you the floor for a presentation of ASML, the world global and monopolist leader in lithography. The floor is yours.
Thank you. And thank you for inviting me to represent ASML on this forum. Yeah, thanks again for letting me this opportunity to represent ASML as a company. On my front slide here, you see an illustration of the obvious fact that chips are omnipresent in our daily life. It is also undeniable fact that no chip could be produced without the ASML technology in between. And today, the goal of my presentation is to open up a little bit towards the answer, what puts ASML in such a unique position in the semiconductor industry. Before doing that, I would like to introduce myself. Apparently, I'm Bulgarian. I'm educated in Sofia University in Faculty of Physics quite some years ago. I also defended a PhD in the Institute of Electronics Bulgarian Academy of Sciences. Continued as a postdoc in Belgium in a number of institutions, the University of Antwerp, and also the Nuclear Research Center in Yale. That followed by a position as a senior scientist in Fraunhofer Center for Nanotechnologies in Dresden, where we also collaborated with Infineon as a company, as presented by the previous speaker. And since 2008 till now, I'm working in ASML on various technical positions, as well as a project lead. And my latest assignment is to contribute to business improvement in order to create increased quality of ASML product. And now I'll start with introducing ASML. If I can. Yeah. ASML, best way to introduce is to show a small video. Yeah, so what is the position of ASML as a company on the global market? Yeah, on the slide here, shown 50 top technology companies contributing to the semiconductor ecosystem and generating about $500 billion per year. These are the results of 2020. You see here on top the position of ASML as a leader in semiconductor equipment producer with about $5 billion per year. And the other companies next by Apple, Microsoft, famous companies. However, they work in a different region of the semiconductor industry. How did it start? In 1984, ASML was founded as a spin-off of Philips. As you see in a garage, and it's similar to other companies. It's well-known fact that humble beginnings make for a very strong can-do mentality. At the beginning, there were 31 employees only. However, beginning in a garage is not a guarantee of success yet. It took decades of perseverance in order to break through the market. And where is nowadays ASML? This is a picture of the campus in Veldhoven. Now the company reaches out to 3 continents. This is the main campus where you also see on the picture in the bottom the new EUV factory built up in order to produce the latest technology machines. It is Europe's biggest tech company by market cap nowadays. Now, what brings us there? Let's talk about technology. And here the roadmap of the many machines produced throughout the years. Starting from the 80s with PAS machines, different types of. In the 90s, the twin scan technologies broke through with new inventions, going through phases of XT and NXT machines. And from 2000 on, the EUV technology started to be developed, with now the new kit in the box, high NA EUV machines with resolution less than 8 nanometers. To make that possible, technology-wise, we had to move mountains. And I would like to mention some of the key innovation factors that were making possible all this roadmap. Of course, first factor here is the decreasing the wavelength throughout the ultraviolet range down to EUV, extreme UV light with wavelength 13.5 since 2011 for the EUV technology, which was a real breakthrough. Next key innovation factor, introducing the immersion lens that made possible imaging much better and with much better parameters of the final image. So using water in between, that was a key innovation breakthrough for the twin scan technology. Then I would like to mention also key changes that brought the step between DUV to EUV lithography. There are 3 main changes: using a mirror optics, then introducing a new light source, and introducing a large vacuum chamber without which the EUV technology would not be possible. But what remains to be said is what makes it possible. And there are 2 factors that are worth to mention. The huge investment in R&D. So it's more than 2.5 billion per year that ASML invests. And then the other factor that I would like to still mention is equally important, the great people that are working together in an integrated supply chain. So we have about 70,000 people in the ASML ecosystem, 35 people working in ASML, employees, 13,000 in R&D, 3,000 in having a PhD or doctorate degree, and I'm proud to be one of them. And last but not least, fact to mention is the open innovation from design to manufacturing. And here it is about the collaboration system that ASML has created with customers, peers, academic partners, such as Technical University of Eindhoven and many others, and also all the suppliers that are contributing to our products. Thank you for your attention, and I'm really very sorry about the technical problems that my presentation was interrupted.
It's okay. Thank you very much for your time and your efforts. In fact, only in the last part there were a couple of portions that we didn't hear, so the overall picture is clear for our audience. So thank you once again, and I hope that we'll start now regular contacts, not only at the level of presentations, but also at a technical level. So once again, thank you very much. Okay, we proceed now with our next speaker from Renesas. Please, it's nice that you're here. Anita Lyubenova, please, you may present yourself and your company.
Yeah, sure.
We can use this
Yeah, just
microphone.
a second, please.
Yeah.
So for the next slide, I push this.
Yeah, this is next slide. This is previous slide. This is the pointer.
Yeah, thank you. Thanks. Good afternoon, ladies and gentlemen. It's a pleasure for me to be with you today. My name is Anita Lyubenova, and so I lead the HR team of Renesas in Bulgaria, and I also hold responsibilities for regional HR for Bulgaria, Switzerland, and Israel. So basically, who are we? Who is Renesas? Renesas is headquartered in Tokyo, Japan, and we are a global leader in providing of microcontrollers. So we have approximately more than 21,000 employees worldwide, spread over more than 30 countries. We hold approximately 20,000 patents and field applications, and have revenue for 2021 for about 994.4 billion yen. So, Renesas was born in 2002 when three major technology giants from Japan, in the name of Hitachi, Mitsubishi Electric, and NEC, decided to merge their semiconductor businesses into one company, forming Renesas. The company started operating in 2010 and began expanding its footprint in Silicon Valley by the acquisition of Intersil in 2017, and then later on with the acquisition of IDT in 2019. In 2021, Renesas has acquired Dialog Semiconductor, expanding its footprint in Europe. And later that year, we acquired Seleno. Now the journey continues with the acquisition of Realty AI in 2022 and the definitive agreement of acquiring Steradium. What is our purpose? So our purpose is to make our lives easier. In order to make human lives easier, our products provide advanced driver assistance systems, alternative fuel vehicles, state-of-the-art medical devices, robotics, and many more products to enhance the way people live. what is the culture within Renesas. So our culture is a guideline of conduct that is spread and shared among the Renesas group and all our employees. Our culture and philosophy is to be transparent, agile, global, innovative, and entrepreneurial. It's key to be transparent and the employees to understand the leadership team strategy and policy, and to be informed regarding all different topics that are coming up within the different units. In the world we live in, we need to take really fast and prompt decisions, so agility is very important. So, Renesas operates in global markets. We have global clients and partners and competitors. So, we need to be able to talk into an advanced language, and not only that, but be able to understand each other in alternative ways by communicating through data and numbers. Innovation is really a key and a heart of a microelectronics company and the world we live in. So it is really important to have the opportunity of our employees to be really innovative and to be creative and improve their work. About entrepreneurial, why is it important? Because if each and every one of us, the employees, takes his job as it is for his own business, we will be able to really stand for our results and look forward into the brighter future. Going forward, sustainability is really a great and big topic for Renesas. It is in the heart of what we do and into the different segments of the environment, the social network, and also the governance. I'm skipping the company data as we already discussed that, but I just wanted to present you with the global network of Renesas. With the dark blue dots, you can really see the global sales network operating across more than 20 countries, and with the light blue dots are marked the R&D centers. So in the, I think it's in pink in this slide. So with the pink, you can really mark our 12 manufacturing sites across the globe. As per Gartner 2021 survey, Renesas holds #1 market share of microcontroller units within the automotive market. This combined with the industrial place number 2 or number 2 market share with 16% of the combined automotive and industrial, and a number 3 with the total semi with 7%. So our mission here is to develop a safer, healthier, greener, and smarter world by providing intelligence to our four focus of growth or segments: automotive, industrial, infrastructure, and IoT. Here are the 4 verticals of our activities where you can really see the products and focus areas of our business. Jumping to EMEA, where Renesas has more than 2,300 employees in 19 countries. Our headquarters in EMEA is situated in Düsseldorf, Germany. So, slightly transitioning to Bulgaria. So Bulgarian entity was established in 2008 as part of the Central Microelectronics Dresden, with headquarters in Varna. In 2012, we added a new location to our activities in Bulgaria by opening our office in Sofia. 2015, the company was acquired by IDT, and in 2019, Renesas acquired IDT. Oh, sorry. The profile of Renesas in Bulgaria, or what we do over here, is design and development of integrated circuits. And the design teams here are mainly focused in development of automotive sensing products. The products that are developed within Bulgaria are sold in million parts all over the world. We continue our sustainable growth in Bulgaria over the years, and with the great support of the management, we are constantly expanding our activities and also expanding the team. So we are actively recruiting, and we are seeing the future in cooperation, like we are just talking today, together with the support and cooperation between universities, the business, and the government. So we are strengthening our relationships with the technical universities in Bulgaria. We are offering long-term internship programs, which are 6 months or more, in both our design centers, Varna and Sofia, where we are giving the opportunity of young and talented people, students, to have the opportunity to learn and practice in a corporate environment, and later on be part of our team. So we're really looking forward to joint science project with the technical universities in Bulgaria and also abroad. Thanks very much for the attention.
Thank you very much. Our next presentation is from Spesima, right? Could you please, the floor is yours. Spesima is a well-known and long-established company in mechatronics, also one of the backbone companies of the cluster of mechatronics. So
Hello.
It's my pleasure to give you the floor and present Spesima in the cluster.
Thank you.
Please.
Thank you. Good afternoon, ladies and gentlemen. I'm Ivaylo Savov. I'm a manager of the service department in the Spesima GmbH. Okay, our company have experience more than 30 years, which means we are 33 years old company, and we have production facilities more than 4,000 square meter. We have more than 25 members, staff, which are working in Spesima. Most of them, they are engineers, doctors, and guys which know how to make automatization and machines. And we have more than 25 patents and trademarks. That is some of our awards that we have in the past and now. From 2004, we have an award for the innovation company. The same award we are receiving on 2012 and 2018. Also, we have an award from German-Bulgarian economy, 2006, and gold medal in 2007, I think, and 2012 on the International Technical Fair in Plovdiv. Our distributor, which are on the worldwide, we are working together with Frey Group and our partner Metal Press, which is for Turkey. Our suppliers, that's not all of our suppliers, but some of our suppliers that we are working together. You can see there is companies which are famous in the world. What we are making? First of all, we are making automatization for die casting industry. We have also a peripheral equipment for the cells, which are mostly for the die casting industry. We have a custom automatization for different customers in the world. And we are integrator of the ABB, KUKA, and FANUC robots. Also, we are making our own control system for the 6-axis robots. For the die casting automatization, we have three main types of machines which we are producing: dosing manipulators, extracting manipulators, and spraying manipulators. These three machines are working together on one die casting machine, and they are producing 24 hours, 7 days a week. First, dosing machines. We have a different size, different type of dosing machines, linear, rotary dosing machines. We can make a dosing with accuracy, accurate dosing from plus minus 2% till plus minus 0.5%. We have a melt capacity for dosing from 0.5 kilos to 30 kilos, and safety feeling functions about these machines, because it's a very dangerous. We are working with melted alloy. Extraction units from 3 to 6 axis extraction units, which are working with die casting machines. Ground fixed load capacity of the extraction unit can be from 1.5 kilo to 50 kilos. And we have also part control, part sensors, and we are making also own grippers for every customer needs. We can make also part controls with the infrasensors, with cameras, with everything that is known on the market. The last one, which we are using in the die casting cell, that is a spraying manipulator. They are making lubrication and cleaning of the molds of the die casting machine. We have 1-axis, 2-axis spraying manipulators. We have a pneumatic manipulators, which the main movement of the manipulators is made by the pneumatic cylinders. We have also with servo drive and different crisis of zones for spraying and cleaning of the die tool. We are producing for this manipulator spraying heads, which are on the model principle, which means that every customer can make own decision about the form of the spraying head which he needs, and about his production. That is part of the spraying devices. We have tanks for the liquid, which can be different types. There we have a diaphragm pumps, and we can make also mixing of the water and the liquid with special dosatron systems. We are, for the peripheral equipment, we are making also for the die casting cells safety fans, cooling station, cooling tanks, and conveyors. That means we can close the cycle of every producer for die casting. That is our control, which we are using, RNC control. We have a patent here for the Wi-Fi hand panel pendant, which is with this pendant we can control every of our units, which means with one panel we can make a control for 3 or 2 or 1 unit what we need. The software also is we have a built-in VPN client diagnostic, which make our units very comfortable to make a service from distance. Doesn't matter in which point in the world is the customer. I say also from the beginning that we are making integration of brand new ABB, FANUC, and cooker robots. And we make also a custom automatization. From the left side, you can see that it's a manipulator which is extracting the rings from the vertical casting machines. And from the right side, that is a one palletizing robot which is working in one Bulgarian company, Rubella Beauty. In the future, we will start, and we have steps. We have naked steps with welding, and you can see that we have also a program which can make a simulation before we start to make a production. Not only with welding, we can make it also with the die casting cells. What we have what delivers Spesima. Spesima deliver research and development. We have a department which make construction of the machines, which make design and everything. We have after sales service. We have a training. We have installation and commissioning. We do everything what is needed for the customer. First, what is important for us, no matter what is the industry, we will help you to identify your needs. We have more than 30 countries worldwide, that we have machines and solution about the customers. We will carefully find the best solution for you, and we guarantee the quality production. And we will provide the training and support for every company. That is some of our customers that using our machines and our automatization. Thank you. That was everything.
Благодаря. Thank you for the interesting presentation. So now we are having 2 more presentations for this panel. Next is Krasimir Trifonov from Arexim Engineering. It's a very interesting company with which we have a lot of successful stories in the recent years, and not only the recent years. Please, the floor is yours.
Thank you. Good afternoon to all of you. I would like first to thank you, the organizers, for inviting us to present our company in front of you. Special thanks to Professor Kralov and Professor Tudorov, who has given our opportunities to present what we are doing. I would like to say that up to now we have been listening about global companies worldwide companies, and speaking for microelectronics. Now I'm going to present you a local company located in Smolyan, which is focused in plastic injection molding. And why plastic injection molding is connected with microelectronics? This is because plastics are like a skin for human body, for microelectronics chips and electronic modules. About the history of the company, later at the end of presentation, you are going to see a short video which represent how the owner of the company started these activities in Smolyan. Company was established in 1991. Why in Smolyan? Because Smolyan was a town of very well developed in tool making and mold making. And at that time, when a lot of people had been jobless, the owner of the company, who has been 23, 25 years old, had been enough clever to collect these people and to start this activity, restart the industry again. Today, his son is with us, and today in the company we have something like transition between old generation and new generation. The company is working in the main business sector of molding of plastic parts and tool making, and I would say that the company is a leader in production of technical plastic products and precise tooling. Business to offer. We have three main manufacturing units. One is injection molding manufacturing unit with 100 injection molding machines. Speaking about the size of the company, companies are local and relatively small for the global view, but from local perspective, 100 injection molding machines is something which is not very often to have on the market, even in Europe. To be good producer of plastic injected parts, you must have a very good equipped tool shop and be very experienced in tool making. And at the end, we offer also assemblies. We put electronic and other mechanical parts in the plastic closures. Main products and markets. You see logo of Arexim, many small plastic parts that are going in soup modules together with electronics, cables, and at the end, all these sub-assemblies are going in the cars. We are company certified with automotive standards in plastic injection business. In Bulgaria especially, we are the only one certified in this standard, and we are giving very precise parts. Probably 90% of the cars in the Europe are equipped with our parts. The other sector in which we are producing plastic parts is power tool sector. On the market, you will find the big players like Makita and Bosch, and 80% of their parts are produced in Bulgaria. You see on the slide one of them, just one of them, but we are producing a million of them. The third sector in which we are working is electric sector. We are producing many million of parts for power breaker switches and many others you can find in your apartments or houses everywhere. You see on the slide our customers and partners. On every sector we have three of the global leaders of the sectors. In automotive, we have a little bit more because in Bulgaria, recent years, automotive sector developed, and a lot of companies from Germany they have local branches to which we are delivering our parts. At the end, again, the parts are going to the OEMs and cars. World map. We are situated in Bulgaria, in the south of Bulgaria, on the border of Greece. We have a very good developed logistic department. All our products we deliver with our departments to not only to Bulgaria, but to all Europe, including Mexico and China. Okay, what we are offering from concept to mass production. We have product development, design, tool manufacturing, plastic part injection, and sub-assemblies. Here you can see some of our partners. Go to the next slide, please. Innovation is a very important part of our development. We have a very successful projects with Technical University of Sofia and Sofia Tech Park. And we continue in this direction. The next slide, please. State-of-the-art tool shop. This is the heart of the company when we are producing the toolings and molds, in which after that we are injecting plastic parts. The tool shop is one of the best in Bulgaria. Recently, we invested more than 8 million euro in new machines and equipment. In this slide, we can see our injection molding department. As I explained to you, we have more than 100 machines, very well equipped with the modern peripheral equipment. We have implemented 10 years now multi-component injection, which is a very specific process. Also, we have overmolding and centralized feeding system for the raw materials. What's interesting, we are proceeding more than 8,000 tons plastic engineering granulates per year. Mainly polyamide with glass field. The next slide, please. Sub-assembly and printing department. We have added value operations on plastics, some sub-assembly modules and automatization. At the end, we are delivering to the customers semi-finished products. Quality control. This kind of production is very sensitive about quality. The accuracy and tolerances are in microns. Somebody showed before very small tolerances.
This is the final.
This is not the final. What the next slide was about the quality certification, and the last one was location, the factory, and contacts. What is interesting is our company is 30 years old. During the last 10 years, we developed 5 times. And now we have a turnover of 80 million euro. To 80% of the products is delivered to foreign countries, and the company is most famous with our foreign partners than in Bulgaria. The reason to be here is to introduce the company and to be known, and for the future, for microelectronics development, electronics development, and industry development, we are here to support this future development.
Thank you very much.
Do apologize for that.
Yeah, thank you very much. Indeed, this is again another good example how we cooperate with the university, with the industry, and we reach the final stage. This is the market. So our last but not least presentation will be David Holding. Balio Dinev will present. Please, the floor is yours.
Thank you very much. I will change the direction. I'm not going to present any related to the electronics directly, but we will go to the mechanical. And especially, I want to present something about the digitalization, because there is so many buzzwords about digitalization, but we have one particular case that would be interesting for you, and this is a real project that I will briefly show you. I hope that bloody device will work. I don't know which exactly button to push. Yeah, about the digitalization. Is there any need and meaning about this? We are living in an analog world with a lot of analog objects world, which is now in accelerated development, and yesterday's good is today's not satisfactory. That's why digitalization is not just an option, and this is a life required necessity. Digitalization isn't a simple task, and this is a big challenge. Digitalization requires knowledge and computer skills, and now we see that the digitalization, there is no alternative about that. Where to start with the digitalization? Why should we digitalize object? Digitizing the objects give us the ability to get into the details. Digitalization gives us to choose the context to work on, and digitalization gives us the ability to have a localization of our effort. What could we digitalize? This is the machine, equipment, structure, objects, and how to do the digitalization. The 3D scanning is just only beginning. The polygons are just the start presentation, and the end result should be the native CAD model that could be worked on. And 3D scanning is just the beginning. We use, I'm showing you the real project that we did about the Russian helicopter Mi-8. This is a huge machine. It's not uneasy even to imagine it. And what is related to the digitalization, this is, I'm sure that no one company did this in Bulgaria. Okay, the key importance is about choosing the right scanner. We use Faro scanner from our friends in Varna. They came in Plovdiv at Avionams, and they did a scanner. They do a lot of scanning from the multiple position. Then we choose the position, and we united in one single model. And it was initially a set of points, which gives us a scanned model could not be edited in any way. This wasn't a CAD models, because it was just the beginning of real work, because we should go to the road from the points to the real 3D CAD model. And the way was from the cloud of point to the STL model, then from the STL model to have a profile curves, and profile curves to the 3D parts, and from the 3D parts to the assembled model, and again the hybrid model down, which was giving us the view about how precise was the digitalization. So this is short video of the 3D assembled model inside Siemens NX format. The model consists of more than 6,000 unique assembled details. This is a big model, 6,000 unique assembled models. No any mutual intersection. All the assembly elements like rivets included inside the model, and all the attributes of the metal parts in this. So you may see how precise and how sophisticated is that model, because this is not a scaled copy, this is a real-time 8 meters helicopter. And what was the reason to do that? Because the reason was to be ready to do the simulation and analysis for the repair of those helicopters. Because the customer is doing the repair of the helicopters. They brought the customer all the helicopters from the Near East, from Africa, and for all the countries which are using Me-8 helicopters. And our customers should do the repair, and this repair is to be very optimized, because any repair means investment in materials, investment in human efforts, and it costs money. And being able to do the analysis of the damaged parts, to evaluate the extent of the repair, the customer is capable to choose what to repair, what to change, what not to change, and to evaluate which component could be replaced with from the other sources, and what is the static and dynamic loads that the alternative parts are giving for the repair. This is finite element modeling did on an entire helicopter, and it is not an easy task, because those are a lot of parts inside. And we give this is done with NX Nastran for the dynamic evaluation of the stress and the limits where the model is able to stand, with ability to predict which part should be replaced with which part should stay inside the model. How we did this project? It was a small team of spacecraft engineers. It was 3 or 4 engineers which used to work for this for 11 months. It was a long time effort. And we used the software products for Forum, reverse engineering for the point of clouds processing. Then 3D system geometric design X for reverse engineering of the scanned model. Then Siemens Solid Edge for 3D part modeling, and Siemens NX for finite assembly and finite element analysis. At the end, few words about the spacecraft. This is company of David Holdings since 1996. The major partner is Siemens Digital Industry Software, a company from the United States, which is internally with Mentor Graphics. Mentor Graphics is related to the electronics. Those who are working for the electronics knows what the Mentor Graphics is doing. Then we offer the solution for the digital design, manufacturing, and product lifecycle management. Engineering services for design, simulation, and manufacturing. And we do the manufacturing of very complex metal details through 3D print in metal. Thank you for your attention. That's all. I want to thank you, Professor Todorov, thank you very much for the chance you gave us.
Thank you very much. Okay, yeah, so all the presentations were completed. Thank you very much. The panel with the 8 companies is over. So now we'll have 5 minutes and then we'll proceed with our round table. 5 minutes rest and then we'll go on.